Okay, here we go with the 2019 AP number 4 question. I have my notes off to the side of the problems for you to work on, the different parts. And here's the original question. I'll read some of the info for you. A cylindrical barrel with a diameter of 2 feet contains collected rainwater. The water drains out through a valve not shown at the bottom of the barrel. So I already kind of know what's going on. I've got liquid in there, some volume. The volume is decreasing. The rate of change of the height of the water is given by this differential equation, dHdt equals negative 1/10 radical h. And they gave me a second piece of information. They gave me a piece of information that the volume of the cylinder is equal to pi r squared h. So, okay, so I'm going to take the problem off so I can change the words a little bit and move it over here. Oops. And correctly give me this rate of change. I put a star on this. This piece about giving me the volume is probably what we're going to have to be taking the derivative of, a related rates problem. They gave me the diameter is 2, but I know it's probably going to come down to the radius of 1. And whenever there's a cylinder problem or a triangle problem involving related rates, one of the numbers is probably not going to change. And we'll figure out how we solve it from there. So they asked me first to find dV/dt. They asked me to find the rate of change of volume with respect to time when the height is 4. And they asked me to give units. So on any related rates problem, we start out with an equation that relates the rate, the quantities. So it's V equals pi r squared h. Now I can take the derivative from here, but is there anything that never changes on the problem? Well, the radius is always 1. So I can rewrite this problem as V equals pi h, because the radius is 1 and the radius squared is 1 squared. So now I've related the quantities. Now I take the derivative to find the relationship on the rates. So the derivative of V is dV/dt equals pi. The derivative of h is dH/dt. And if I want the dV/dt when h is 4, it's going to fill in 4. I've got pi. dH/dt is this equation right here. So it's times negative 1/10 the square root of the height. And the height is 4. And take a look at how this problem works out. I could leave it like that, but it's going to be negative 2 pi over 10 or negative 1/5 pi. Doesn't matter. Now they ask me for units. So all I have to do is check what things are measured in. So let me find, this is dV/dt. Let's take a look. So if height was measured in feet, volume is feet cubed. So that means that the units of measure for dV/dt is feet cubed per whatever the problem says it's measured in seconds. How did I know feet cubed per second? I looked at the problem. I found feet was our unit of linear distance. I found seconds was our unit of time. So if they asked me for area, it would be feet squared. Volume would be feet cubed. Okay, let's take a look at the next part of the problem. It says, I'm going to put it off to the side right here for a minute. B, when the height of the water is 3 feet, the rate of change of the height of the water is the rate of change of the height of the water with respect to time increasing or decreasing, and explain your meaning. Okay, so there's a lot of words in here. First thing I know is that when the height is 3. That's one thing. I know what time I'm looking at, which is right here. And I got to be really careful what they're asking me for. It says, is the rate of change of the height of the water increasing or decreasing? So they want to know if which thing is increasing or decreasing. They want to know if dH/dt is increasing or decreasing. When I want to check to see if something's increasing or decreasing, I'm always going to check its derivative. So I have to look at d squared h over dt squared, which is the derivative of dH/dt, and see if there's what that's going to be. So to do that, I'm going to take the derivative of the top equation right here. So it's going to be negative 1/10. And I'm going to, in my mind, convert this to h to the 1/2 power. So that would be 1/2 h to the negative 1/2 power. And I want to know what's happening when t equals, when h equals 3. What's happening to dH/dt when h equals 3? So I had to make sure that when I took the derivative of this statement right here, everything's based on time. So after I found 1/2 h squared for here, I have to multiply it by the derivative of h, which is dH/dt. And then all I'm going to do is fill in numbers as we go. So I've got negative 1/10 times 1/2, 3 to the negative 1/2, times dh dt at 3. I've got to fill it back into there, negative 1/10 times 3, also times radical 3. Now, let's just take a look at, I don't care what number I end up with, I just care what the sign of the answer is going to be. So if I look here, I know that 3 to the negative 1/2 is positive, so this is positive. I know this answer is negative, I know this is negative. All these together give me a positive, and it is increasing. Since this is the explanation, d squared h over dt squared is positive. If you don't want to write dhet over dt squared, you can do h double prime, however you like to write it. That's just the standard way they write that one out. Okay, so the last part says that time equals 0, the height is 5 feet. Use separation of variables to find an expression for h in terms of t. So once again, this is going to be a differential equation. So I'm going to separate, integrate, solve. I'm going to start with the differential. Get a better marker than this. Let's start out with dh over dt equals negative 1/10 square root of h, which I'm going to write as h to the 1/2, just to make my life easy as time goes by. I'm going to put this over 1. I'm going to cross multiply, and I get dh equals negative 1/10 h to the 1/2 dt. Okay, so I've gotten that far. Now, the only problem is I don't have the h's stuff on h's and dh's on one side. So I'm going to bring this over to the other side, just the h, and I'm going to end up with h to the negative 1/2 dh equals negative 1/10 dt. You could have brought the constant to the other side as well. Doesn't matter. The reason I did this the quick way was I know if it's h to the 1/2 power on this side, moving it to the other side makes it h to the 1/2 power. I've now separated. I'm now ready to integrate. I will integrate both sides. Going up 1 unit brings me to h to the 1/2 with a 2 out front, the flip of it, equals negative 1/10. This is based on time t plus c. So there's my solved equation. And they gave me a specific value. They want me to find c when t is 0 and h is 5. So let's fill that on in. So we end up with 2 times 5 to the 1/2 power equals negative 1/10 0 plus c. So that means that c is equal to exactly what this is right here. Now we'll have our calculator so we can find it out. I'm just going to write it as 2 radical 5 for right now. You can leave it as 2 5 to the 1/2. And now I'm going to rewrite the equation over here and get h by itself. So the equation is 2h to the 1/2 equals negative 1/10 t plus 2 radical 5. Okay, first thing I'm going to do is I'm going to divide each side by 2. And then I'm going to put everything to the second power. So I end up with h equals negative 1/10 t plus 2 radical 5 over 2 squared. There we go. Okay, folks, take care.